Hi, in this video we're going to be looking at how the chain rule can interact with other derivative rules that we know about. So we are again talking about the chain rule. We are looking for what is the inside part and what is the outside part of our function that we're trying to find the derivative of. So in this example down here, our outermost part is this cube, but then inside of that cube, we have a natural log. But that doesn't just mean that when we find the derivative, it's just going to be straightforward like that. For this example, when we're applying the chain rule, the inside part actually uses quotient rule. We've got sine x over 1 plus cosine x. That's going to need chain rule when we're hunting. Not chain rule, we're going to need quotient rule when we're looking for the derivative of that inside. So u prime is going to be the derivative of the top, which is cosine of x, multiplied by the bottom, 1 plus cosine x, minus the derivative of the bottom. Derivative of 1 is 1. Derivative of cosine is negative sine, multiplied by the top, which is sine x. And then this is all over that denominator squared. This is just the inside. Oh, man. Oh, man. But now at least we know what the derivative of that inside is. So when we're looking for y prime, we would do our regular power rule on that exponent of 2. So the 2 would drop in front. We do nothing with our inside. It just sits there for now. Subtract 1 from our exponent. So it's just going to be 1. And then we need to multiply it by this big green thing. Now, rather than just straight copying the big green thing, I'm going to simplify it a little bit. I'm going to make this a 1 plus cosine x squared. So I lied. I'm not going to simplify that at all. But this I'm going to distribute. So we'll get cosine x plus cosine squared plus sine squared. Because I've got a negative sign times sine, so that'd be negative sine squared, but there's a minus in between them, so it becomes plus. Now that I've done that, I'm looking, cosine squared plus sine squared, Pythagorean identity, cosine squared plus sine squared, that's just 1. So this big chunk right there, that's just a 1. Ah, cool. So this is really 1 plus cosine x over itself, 1 plus cosine x squared. So we'll be able to cancel a little bit. We still got this stuff over here. So this is y prime equals, I'm going to make this a 2 over 1 so I kind of remember, hey, that 2 is in the numerator. Sine x over 1 plus cosine x. I'm going to choose to cancel the one that doesn't have a squared on it, just because then I don't have to cross out the squared. So this equals 2 sine x over 1 times that denominator isn't going to do anything. 1 plus cosine x quantity squared. And there is our derivative. Ha-ha! Neat. Okay, now I need to find the derivative of this one. Now they've mixed it up a little bit, and they've given us an r and a theta instead of an x and a y, but big whoop. We still want to find the derivative of this thing. So when I'm going after that r prime, I'm going to need to use the product rule on this one. Oop, that is not a pen. How about this? R prime. I need to do the derivative of this thing. So in order to find the derivative of secant, I've grabbed this off of my cool calculus card. I know it is going to be secant of that 2 theta times the tangent of 2 theta. But then I need to apply my chain rule. So I need to do the derivative of what was inside of secant. It wasn't much. It was a 2 theta. So I'm not even going to really write it down. I know what the derivative of my inside would be. The derivative of this little piece is going to be 2. So I'm just going to multiply that thing by 2. Then I need to multiply that by the second thing. So that's a tan of 2 theta. Then I need to do the derivative of this piece, the tangent of 2 theta. So the derivative of tangent is secant squared. So plus secant squared of 2 theta. And again, I need to do the derivative of this piece, derivative of the inside, derivative of 2 theta. We just did it. It's 2 again. And then I need to multiply that by the first thing, which was secant of 2 theta. All right, now it's just a matter of we can clean this up just a touch. This has got 2 tangents in it. So let's call this a 2 secant of 2 theta and call it a tangent squared 2 theta. Plus, this has got 3 secants in it. So it's 2 secant cubed 2 theta. Not a huge amount of cleaning up, but just a little bit. And that's it. It's done. So again, when using the chain rule, make sure you're looking to do the derivative of the outside and then multiply that by the derivative of the inside. This can be mixed with other derivative rules that we have learned as well. Thanks for watching. Bye-bye. Now goodbye.